everyone! In this virtual lab, we're going to study the stretching of copper. Actually, copper behaves in a different way from the materials we have studied so far, like glass, aluminium, and steel. Let's click on Specimens and select the short thin copper specimen. And let's select a graph in order to plot the relation of load versus extension for the copper specimen. And now we will gradually increase the load on the specimen until it reaches 100 newtons. Watch the graph develops as we are increasing the load. The load versus extension relationship started as a straight line obeying Hooke's law. Remember that Hooke's law represents a linear relationship, or is a proportionality between the load and the extension. And then, at this point, there's a change in the graph. So at what value of load does the graph change the slope? Yes, at 40 newtons. What happens to the behavior of the specimen at this point? Exactly, it becomes much easier to stretch the specimen. So with a little load, the specimen extends significantly. What do we call this point? Yes, the elastic limit. Let's recall its definition. We'll click Definitions and go to Elastic Limit. So the elastic limit is defined as the load beyond which an object becomes permanently deformed. If the load is less than the elastic limit, the object returns to its original size when the load is removed. So let's explain it on this load extension graph. First, while loading and before reaching the elastic limit, the relationship between load and extension is a straight line. And while unloading in this region, the object will return to its original length. And we say that this material obeys Hooke's law. However, the load is greater than the elastic limit. So, if we increase the load on the object, reaching the elastic limit, and continue increasing the load, and then at some point unload the specimen, it will return back to its original length. But here, it won't return back. There will be a permanent extension, and we say that the object is deformed. It exceeds the elastic limit. So, if the load is greater than the elastic limit, the object is permanently stretched when the load is removed,